Hello, in this video we're going to take a look at some examples of solving quadratic equations using the factoring method. So anytime you are using factoring to solve an equation, whether it's a quadratic or a higher order, we always want to make sure that we get everything on the same side. We cannot start factoring unless it's equal to 0. Alright, so our first example we have here is 4x squared minus 64 equals 0. It's already equal to 0, so that part's done for us. Now we want to factor that left-hand side. Just like when we were factoring with expressions, the first step is to always look for the greatest common factor. So between 4x squared and 64, they're both divisible by 4, so we can factor out a GCF of 4. We can't pull out any x's because there's not any x's on our 64, but that's going to leave us with x squared, and then negative 64 divided by 4 is negative 16. X squared minus 16 is a difference of squares, so it's going to factor to x plus the square root of 16 and x minus the square root of 16. When we're solving by factoring, once we have it all factored like we have here, we want to set each of those factors equal to 0. 4 equals 0, x plus 4 equals 0, and x minus 4 equals 0. Well, there's no x in our first factor, and so unless you factor out a GCF that involves an x, you're not going to get any solutions from that equation because there's no x there to solve for. X plus 4 equals 0. We're going to subtract 4 from both sides and get x equal a negative 4. And then x minus 4 equals 0. We're going to add 4 to both sides and get x equal 4. So our solution set is negative 4, 4. You could also use that plus or minus 4 as the solution. You will always have the same number of solutions down here if you count anything that's repeated as the degree of your original function. So here we have plus 4, minus 4, so we've got 2 solutions, and our original function was a quadratic, and so that means we have 2 solutions. All right, our next example, we have 9x squared plus 4 equals 12x. So on this one, we're going to have to move everything to one side before we do it, any factoring. And so let's subtract 12 from both sides. I am going to rearrange this and write it in decreasing powers. So I'm going to do the 9x squared, and then when we subtract 12x, we'll get a minus 12x on the left and a plus 4. I always move it whichever direction I need to in order to have a positive coefficient on my biggest power. So in this case, the 9x squared, I want it to be a positive. So I'm going to leave that one where it is and move everything else. If that had been a negative 9x squared, I would have moved everything to the right just because it's easier to factor with a positive coefficient. All right, 9x squared minus 12x plus 4. We're looking for factors of 9 times 4. 9 times 4 is 36. Factors of that add to negative 12. Well, since this is a positive 36, that means these have to have the same signs, and if they add to a negative number, that means they have to be a negative. So both of these numbers are going to be negative, and the numbers that multiply and give us 36 and add and give us 12 here are going to be negative 6 and negative 6. Those are the same number, and so that means this is a perfect square trinomial, and it's going to factor to the square root of the first one, and 9x squared, the square root of that is 3x, and the square root of the second one, square root of 4 is 2, with whatever sign we had on our 12, in this case a minus squared. If you don't recognize that, then you can use whatever method of factoring that you're most comfortable with. I'm going to go ahead and use the box method on this one. So we have 9x squared and then negative 6x. I'm going to make a box. We're going to put our first term in the top left-hand corner, our last term in the bottom right-hand corner, and then our two numbers that we came up with times x, and then factor out the GCF. So 9x squared and negative 6x. That we're always going to take the sign that's closest to where we're writing it. So this is going to be 3x is going to be the GCF. And then negative 6x and 4 has a GCF of 2, but since the negative is closest, we're going to pull out the negative with it. And then 9x squared and negative 6x, we're going to take what's closest to it. That has a GCF of 3x. And then negative 6x and 4, again, is a 2. But since that negative is right next to it, we'll pull out the negative 2. We do see 3x minus 2. 3x minus 2 equals 0. And so this will only be equal to 0 if 3x minus 2 equals 0. You can think of this as taking the square root property, taking the square root of both sides, and we get plus or minus 0 here. Okay, we're going to add 2 and divide by 3, and we get x is equal to 2/3. Here we only have the solution 2/3. This is a quadratic, and I just said on the previous example you'll always have the same number of solutions as the degree of your problem. But remember, this is a plus or minus 0. So we get 2 plus or minus 0. So we actually get, this is what we're going to call a multiplicity 2, because they're both the same, but it is a repeated solution. All right, our last example that we're going to look at in this video is 30x minus 11 equals 30 over x. Now this doesn't look like a quadratic at all, because a quadratic, remember, has to be in the form of ax squared plus bx plus c, or it has to at least be able to be written in that form. And this one, we don't have any x squareds, and we've got an x in the denominator. But anytime you have a fraction with an equal sign, you can always multiply by the LCD of your denominators. In this case, our only thing that we're multiplying by is x, but if we do it on one side, we have to do it on the other side and distribute. So if we do that, multiplying both sides by x, that's going to give us 30x squared minus 11x on the left, and 30 over x times x. Those x's are going to cancel out, and we're left with 30. All right, we want to get everything on one side, so we can write it in that form. And so we'll subtract 30. All right, here we're looking for factors of 30 times negative 30. Well, 30 times negative 30 is negative 900. Factors of negative the 900 that add to a negative 11 are going to be, let's see, 25 and 36. All right, if you're not really sure how to get these, you can use your calculator. All right, so to use your calculator, you're going to want to go to your y equals menu. You're going to want to put the number we're looking for, in this case, negative 900, and divide it by x. This is a quick way to get all of the factors of it. And then you're going to go to, first, I'm going to go to second window to get my table set. Make sure that both the independent and the dependent are listed as auto. And then go to your table by doing second graph. And what you see here are all of the factors of the number that we put in the numerator, in this case negative 900. And so what we're looking for is we're looking for a set of numbers that have a difference of 11. Well, 1 and 900, 2 and 450, these are all way too far apart to have a difference of 11. Let's see, 15 and 60, we're still too far away. 18 and 50 is still too far away. But when we get to 25 and negative 36, 25 and 36 do multiply and give us 900, or negative 900. We want them to add to a negative 11, so that is actually the combination we want. 25 plus negative 36 is going to be equal to negative 11. So we want 25 and negative 36. All right, on this one, I'll go ahead and use the amazing method. So the amazing method, you take your first coefficient times your variable, in this case 30 times x, and divide it by each of those numbers. 30 times x over negative 36. This is a different version. Some people call this the x method or the t method. It works the same basic idea there. And now what we're going to do is we're going to reduce these fractions. So 30 and 25, that reduces. They're both divisible by 5. So 30 divided by 5 is 6, and 25 divided by 5 is 5. 30 and 36 are both divisible by 6, so when we divide out, we're going to get a 5x and a negative 6. And then we're just going to lay those down. So our factors are 6x and a positive 5 from this first fraction, and 5x and a negative 6 from the second fraction. If you are asked to solve by factoring, give me the step that shows your factors. All right, now we're going to set each of those factors equal to 0. Subtract 5, divide by 6, and we get negative 5 over 6. And then we're going to add 6 and divide by 5, and we get a positive 6 over 5. So that is our solution set. Negative 5/6 and 6/5. All right, I'll see you guys next time.